Okay, so I've written a parametric function up here. So with no technology, can you describe that function, right? So can you maybe sketch it? But more than just sketching a set of points, there's more to it, right? What is there more than just, how is there more to that parametric function than just a set of points? Right, so there's, it's like, how is the curve generated? There's this aspect of parametric functions, like as t increases, how is the curve generated? That's, you've seen that's really important, right? So can you describe this set of points, but not only this set of points, but how it's generated? So based on your knowledge of sine and cosine, and what's going on here with the argument, can you, without technology, kind of qualify or describe this this function? So if the homework made sense of the homework, then you should be able to do that. So maybe these, just a reminder, these functions might help. Okay, you're making progress, or you're talking with somebody? Give a full description without using technology, a full description of this parametric function. Full description without using technology. That would be a fair quiz to have right now. So my hope is that you're thinking, what, covariationally. That's the kind of the whole point of, what does that mean when I say that we want to analyze this? Using the idea of covariation. That's how we've been trying to train you in this course. So what does that mean, covariation? Yeah, good. She said two variables are varying together. So, and if we want to make heads or tails of this, how do we think of this as how are we going to use covariation to make heads or tails? Did anyone do that? For instance, as what? As t goes from 0 to 1, right? As t changes, then how do x and y change, right? How do x and y change? So in terms of looking at functions and variables, we want this to become your instinct. This whole calculus is all about variables changing together, right? Rate of change, accumulation of dependent variable versus an independent variable. Okay, so as t goes from 0 to 1, what can we say? What do we care about? As t goes from 0 to 1, we care about what? What x and y are doing, right? So, Josh, did you do anything like this when you talked about it? Somewhat. Okay, so can you take it from there? So as t goes from 0 to 1, what can you say?
From 0 to 1, y goes from 1 to 0.
1 to 0? Is that what you said? Yep, y goes from 1 to 0 because it's the cosine is going to go, this argument will go from 0 to pi over 2. And as you go from 0 to pi over 2, cosine will go from 1 to 0. What about x? 0 to 1. So that right there, so what can we say? As t goes from 0 to 1, what do we have? What's going on? Anyone describe what's happening there as t goes from 0 to 1? Yeah, Nick.
First quarter of the unit circle on the first quadrant.
Starting from where?
Starting from the point 0, 1 to 1.
Okay, so looking at that, right there, as t goes from 0 to 1, x goes from 0 to 1, y goes from 1 to 0. We think about what? Right, it's going to generate those points right there as t goes from 0 to 1. You see that? Because why? Our x-coordinate is going from 0 to 1, while our y-coordinate goes from 1 to 0, because it's cosine. So he says the first quarter of the unit circle. Okay? And then we do not, what do we do next? We say as t goes from 1 to 2, what will x do? So now we're talking about the sign. X will do what? 1 back to 0, and y will do cosine now. So as t goes from 1 to 2, we'll have cosine from pi over 2 to pi. So cosine will do what? 0 to negative 1, right? So what will that be? Second quadrant? Fourth quadrant, right? Fourth quadrant. So x will go from 1 to 0. X will go back to 0 while y goes down to negative 1. And we get the second half of the second quarter down in the fourth quadrant, right? In the fourth quadrant. So what is this function doing? This function does what? In general. Kellen, what do you think? What does this function do?
I think it moves clockwise with a radius of 1.
So this function generates a set of points. What set of points does it generate? The unit circle, but more specifically? So yes, the unit circle is a set of points, but there's this very important aspect of parametric functions besides just the set of points. What else is there? Yeah, with respect to t, right? So as t varies, we get those points generated in a certain way. So we get the unit circle generated how? In this particular function. Okay, clockwise. Anything else? Starting at 0, 1, right? So it's starting when t equals 0. We start at 0, 1. And this particular function generates the unit circle in a clockwise manner. Okay, so that's our expectation for how you would think about this. You think about as t changes, how does x change? How does y change? And then what set of points are being generated as t increases? Okay, so let's take a look at this. What is the equation of that circle? So that circle has an equation just of x and y, not parametrically. What's the equation of that circle?
X squared plus y squared equals y squared.
X squared plus y squared equals? Yeah, so our general form would be r squared, but r is 1, so it'd be x squared plus y squared equals 1, right? So if this is the same, if these are the same set of points, how are they the same set of points? X squared plus y squared equals 1, and x equals sine pi 2 over t, and y equals cosine pi 2 over t. How is it that those are the same set of points? Anyone see the connection there? Yeah, Cody. Tell me. Yeah, tell me. Okay, nice, very good. So if we took sine, we took that and squared it, and then we took the cosine and squared it, and this only works because the arguments are the same, right? You got to have the same argument, the same thing going into sine as going into cosine. according to our trig identity, what would that equal? 1, right? We have this trig identity that says sine squared plus cosine squared equals 1. But what is that? What is that thing that I squared? What is sine pi over 2t?
X.
It's x, isn't it? And what is cosine pi over 2t? Y, right? So this equation right here, which we know is true as a trig identity, is the same thing here as saying that x squared plus y squared equals, and that's what we said. That's what you told me the equation of the circle was. But what does x squared plus y squared equals 1? How is it, what does it lack that this parametric function has? So x squared plus y squared equals 1, and this parametric function, or this one up here, how would you contrast those? What does this have that this doesn't? Okay, it has a parameter, and what's the effect of that? Right, direction and starting point, right? So this has implied with it this idea that when t is 0, we start at the top of the circle, and then the points are generated how? Clockwise as t increases. What about this? Does this have any of that? No, this is just, boom, set of points, right? So you get the same set of points, but with a parametric function, there's this whole aspect of when t is 0, you get a certain point, and then as t increases, you generate ordered pairs in a certain direction. In a certain direction. You see that? Okay, let's try another one. So here's one. Three cosine pi t, 2 sine pi t. So think about this, approach it in the same way that we did the last one, or that I kind of encouraged you to do, okay? So without technology, what's going on here, right? So what is this function all about? What is this function all about without technology? And how are we going to think about it? Covariationally. Okay, I'll start attendance, give you a couple minutes, see what you come up with. No technology, no calculators, right? No Okay, let's see how you did. Rebecca, any progress? All right, hold on a sec. Yeah. As t goes from 0 to 1, 3x goes from 3 to, and does it pass anything along the way? Okay, and then what about y? How'd she do? That's right. Good start. Okay, good start. So as t goes from, so we're going to start at x equals 3, and we know we're going to go back, as x is going to do this. It's going to go through 0 and end up at -3, as y does what? Starts at 0, goes up to 2, and back down. So can you imagine how that will play out with the ordered pairs, right? So as x goes here from 3 to -3, and y goes from 0 up to 2 and back down to 0, what will we get? Will it be a circle? Is it going to be the unit circle? No, it's going to be, yeah, something like a stretched or a smushed circle, right? And how will that be generated? Counterclockwise. Starting at 3, 0, right? Starting at 3, 0 counterclockwise. Because x is going to decrease, and then y is going to go up. So we're going to go up and back to the left at the same time, right? Is that what you're imagining? And then as t goes from 1 to 2, what's x going to do? We're at -3, and so it's the cosine, right? So we're going to go from cosine of what? Pi to 2 pi, right? As t goes from 1 to 2, we'll go from cosine of pi to 2 pi. And that means that x will do what? -3? Yeah, me too. All right? And then y? It's at 0. It's going to go down to -2. What are we talking about? We're talking about sine of what? Sine of pi to sine of 2 pi as t goes from 1 to 2. So we're going to go from 0 down to -2 and then back to 0. So that will do what? Finish it, right? We'll go back, still going counterclockwise. And so we get this ellipse. Okay? So how can we get the equation of the ellipse? Just an equation of x and y. Get rid of it, eliminate the t. So how can we do that? So we want to use the same identity that we had before. So what's true in that identity? We know that what? Cosine of pi t squared plus what? Sine of pi t squared equals 1. So now how do we get x's and y's involved? Is cosine equal to x?
No.
What is cosine equal to? X over 3. Do you see that? Because x equals 3 cosine pi t, then cosine pi t equals x divided by 3. Do you see it? So we have a little function there, and if you isolate cosine pi t, it's going to be x divided by 3. So cosine pi t is x divided by 3. Same thing, what's sine equal to? Y divided by 2. So we get x squared over 9 plus y squared over 4 equals 1. What is that? That's the equation of ellipse with horizontal directrix, or this length right here, is 3. And this is 2. And that's exactly what that is right there. But tell the person next to you, what's different about this equation of this ellipse and the original parametric function that we started with? So there's a big difference between, so what's the same and what's different, right? What's the same about this parametric function and this equation? And what's different about this parametric function and this equation? Go. Okay, what's the same? What's the same? Yeah. Let's see. Okay, Kylan, what's the same about those two?
Both functions give you the same coordinates, so they'll give you the same graph.
Right.
But the parametric function gives you the direction that it's being generated.
Right. Right. And also, yeah, so there's, right, so this, yeah, starting point for t equals 0. Where t equals 0 is here, right? So t equals 0 is here, and it's generated what direction? This one's counterclockwise, right? Yeah, so she nailed it, right? So that what's the same about them is they generate the same set of points. That blue curve that you're looking at, what, is a zillion points, coordinate points, right? Both of those equations generate those points. But then the parametric function has more to it. You could talk about where does it start, and that would be like t equals 0, and then how are the points generated as t increases. In this case, counterclockwise. Okay, so let's reverse it then. Let's take it the other way. What's going on? There we go. Okay, so how about this example? If I can read 16. It's a new example. So now I'm going to give you the equation. I'm going to give you an equation, and I'm going to say, what is that set of points, and could you write it parametrically? Right? So what is that set of points without technology? What is that set of points, and could you write it parametrically? Give it a shot. I'll finish attendance, okay? So okay, Ani. Did you end up with, was your first step to write it something like this?
No.
Okay, it's honest, okay. This might help. So where we're going, I might suggest this might help us out. So what would it be? So if it was 16x squared, that's x over what all squared? 1/4? Did some of you get that? And then it's y over what all squared? 3. So this is our first step. So from here, we could sketch this thing. How far do I going to go out in the x-axis? If I wanted to sketch this, I could from here. I'm going to go over 1/4 in the x-axis. And then what about y? 3. -3 to 3. So we're going to get this real tall, skinny ellipse, right? Standing on its end, right? A real tall, skinny ellipse standing on its end like that. Okay, but now if we want to write this parametrically, how does this help us write parametrically? Anyone get that far? Was that a hand?
Yeah, it would be x equals 1/4 cosine of pi t.
Okay, so yeah, so look, so inside here, to maintain this thing of something squared plus something squared equals 1, then inside these parentheses, she's saying inside those parentheses make it cosine of, you said pi t?
Yeah.
That's fine. And then inside these parentheses,
3 sine pi t.
okay, so before we get, so I'm just going to write, so if we were to plug in cosine pi t in for here and sine pi t in for here, we still have a valid equation, right? Because it'd be cosine squared plus sine squared equals 1. So then this thing here equals cosine pi t, which means x equals what? So this equals cosine pi t, so x would equal 1/4 cosine pi t. Do you see it? And if this y over 3 is equal to sine t, then y equals? Okay. Did I lose you, or does this make sense? So it's all this translation from an equation to a parametric function is all about this relationship of sine squared plus cosine squared equals 1. So I wrote it this way to set that up. And then I said, okay, inside here I want that to be cosine. That would mean x would be 1/4 times cosine. is if x over 1/4 is cosine, and I solve for x, just multiply by 1/4. Same thing with the sine. Yeah.
So that one, your argument is pi t, but then in the other example it's pi 2t.
Okay.
How do you determine
So the argument, pi t, she's saying, in the previous example it was pi over 2t. Which is right? Which is right? Can I do pi t, or do I have to do pi over 2t? Bryce?
You could put any number right in front of it because that's the information that you use when you just take the output.
Okay, so what changes when I change this coefficient, right? I could have pi over 2, I could have 2 pi.
The speed at which it's generated.
Yeah, so it's just as t goes from 0 to 1, you're going to get more or less of the points, right? Depending on what your coefficient is. So we could make it real simple, and we could just say x equals 1/4 cosine of what? T. And y is 3 sine of? We're going to get the same ellipse. It's just that as t goes from 0 to 1, we're going to get how much of it? 1 radian, right? We're going to get 1 radian because we're going to get when t reaches 1, we'll have 1/4 cosine 1 and 3 sine 1. So now it's just t is going by just straight radians, right? And so how much t would it take to generate the whole ellipse? So t would need to go from 0 to what to generate the whole ellipse in this form? We're not doing degrees, right? Nothing to do with degrees. So to get the whole ellipse, t would have to do what? 0 to 2? 2 pi, right? To get the whole ellipse, we need 0 to 2 pi. But in this one, what would t need to do to get the whole ellipse? 0 to 2, right? So this is going to get us the whole ellipse. Cosine pi t and sine pi t is going to get the whole ellipse for less change of t, right? Only 0 to 2 will get us the whole ellipse. But this one will take, t will have to vary from 0 to 2 pi to get the whole ellipse. Okay, so we can change the argument to anything we want as long as they're the same, right? They've got to be the same. Is there any other ways we could write this parametric function? Is there a different way to write it? X equals? Y equals? What's that? Okay, tell me why, Josh, or give me another one. So let's keep the argument just as t. Okay, we'll just stick with t. How else could I write this that'll generate that? Yeah.
You have any coefficient for t, and it'll still create the same graph.
Right. So we're going to keep it at 1. And so rather than change the coefficient, is there something else we can change to get the same graph? Like, look at the very first example we did today. Is that how? Is that right? So what were you were nodding your head like you had an epiphany. So how else can I write this function to generate the same ellipse? So I could do 1/4 what? 1/4 sine t and 3 cosine t. And how would that be different? So again, we're going to get the same set of points, but now as starting from where's this t equals 0 going to give us? What point? The top point, right? Now, instead of starting here and going counterclockwise, this form of it will start at the top and go clockwise. So, like he said, there's going to be an infinite number of ways that we can describe this set of points as a parametric function. All right? So, what if I want to start at this point what point is that? Negative 1/4, 0. And I want it to be generated, say, clockwise. Could we come up with a way to do that? I want to get the same ellipse, so let's plot the ellipse. What do we say? 16x squared plus y squared over 9. And red seems to be the theme here. Okay, so that's what we thought. Right, there it is. But now I want a parametric function that starts it here at negative 1/4, 0 and generates the point clockwise. So generates the points this way. Can you do it? But I want t equals 0 to be right there.
Pi over 2 over all over 4, y equals 3 cosine pi t minus pi over 2 all over.
Okay, so you shifted t. That's perfectly legitimate to shift t. I had something else in mind though. Okay, so what he did was great. He just took t and shifted it, right? So he's shifting t by pi or pi over 2 based on one that he's already done. So I'm thinking of a different way to do this though. Thinking of a different way to do this. So as t goes from 0 to 1, we want x to do what? X to go from negative 1 to 0 to, or so, sorry. Sure, negative 1 to just to 0. It's just negative 1 to 0. Okay, and then y? We want to go from what to what? So starting here, 0 to, sorry, negative 1/4 to 0. And then y goes from 0 to 3. So what's another way to achieve that? How can anyone see another way to achieve that? What about y going from 0 to 3? And then in the next quadrant back to 3. So the y is easy. Y can be what? Just sine, right? That's just going to be sine t. What about x? So now we need x to go from, and actually it's going to be, the way I'm writing this is going to be pi over 2, right? Pi over 2t. Okay, what about x? I need x to go from negative 1/4 to 0 to positive 1/4 to 0 to negative 1/4. So it's like cosine, but it's just what? Related to cosine. Just negative. And then how does that still get us the same equation of the ellipse? What happens if we do what? X squared, or if we do cosine and sine? What happens when you square a negative, right? It just becomes positive. So really, we can choose plus or minus cosine and plus or minus sine and assign them to x or y to have all these different possibilities of starting point and direction. Do you see that? So there's 8, right? There's 8 possibilities because there's 4 starting points and 2 directions. That's 8 possibilities of where to start and which way to go. And those can all be achieved by x being either plus or minus sine or plus or minus cosine, and then y being plus or minus sine or plus or minus cosine. But they can't both be sine or both be cosine. See that? Yeah, Nick.
I have 2 questions. One, would it be just as legitimate to restrict the range of t, or domain of t, so that we just said t starts at 2 rather than t starts at 0? Or is that a different function?
No, so I wanted t, yes, so that's another way to do it, but I wanted t to be 0 here. I wanted t to be 0 here and generate clockwise. So to do that, I'm going to need negative 1/4 cosine and positive 3 sine. And that will generate the points clockwise starting from negative 1/4, 0. Is there another second question?
Yeah. And would we ever choose a point between the 4 endpoints, like
If you did, then you'd have to shift t the way that Andrew did it the first time. You'd have to like do a t minus something or t plus something. Yeah. Is there a hand over here? Okay. So how about can you write it so it starts at the bottom and generates counterclockwise. So how can you write this parametric function of this ellipse so that t equals 0 is here at the bottom of it, and it's going to generate counterclockwise? This was what? This started at the left side and generated clockwise. So start at the bottom and generate counterclockwise. Can you do it? So what will the x-coordinate be? Will it be sine or cosine? And then will it be positive or negative sign? Positive sign, right? X is gonna go from 0 out to the max, back to 0 as you go clockwise. So it's gonna be sine. And we need it to be 1/4 sine. And again, the argument doesn't matter, right? So I could put t, I could put pi over 2t. Just know that more or less of the curve will be generated for the same change in t. So I'll just do t now. All right. And then what is y doing? Y is starting at -1 and going to 0, and then -3, then up to 0, then 3. So what would that be? Negative or positive cosine? Negative cosine. So it'd be -3 cosine. And if we do the math on this, if we isolate the sine and the cosine and square them, we'll get the exact same equation of the ellipse that we have up at the top there. Okay, one more thing. So for this last one we did right here, so it starts at t equals 0, it generates counterclockwise. What would be true about, at this point right here, dx dt and dy dt? Dx dt and dy dt. So dx dt is what? For a small change in t, it's giving you the change in x. So right there, for a small change in t, what's the change in x? It's heading straight vertically, right? So there's no change in x, right? So if we took dx dt, we would get what? No, so dx dt is a function, right? dx dt is a function. What was that function in this case? 1/4 cosine t. And we were talking about t equals pi over 2, right? So this would be starting down here, going a quarter circle would be pi over 2. And so what is 1/4 cosine pi over 2? 0. So dx dt is 0. That's what we predicted right there, because for a change in t, x right there, x doesn't change because it's heading straight up. It's not moving left or right there at the side. So our dx dt is 0. So what is it? It's like a relative maximum of x. Relative maximum of x. Because we have the derivative dx dt is equal to 0, and we're getting like the max value of x at that point. All right, what about y? So what can we say about dy dt at this point? For a change in t, what happens to y? Little change in t around this point. What happens to y? For a little change in t around this point, as we're traveling, the curve is traveling this way, right? The points are being generated this way. For a little change in t, what happens to y? I'll give you some choices. It's decreasing, 0, or increasing? Truly increasing, which means we expect dy dt to be positive, right? So let's do it. dy dt is positive 3 sine t, and we're looking at pi over 2, 3 sine of pi over 2, greater than 0, right? So the rate of change is 3, meaning for a change in t, your change in y is what? 3 times as great as the change in t. And that's a positive increase, right? Okay.